Hello, you guys. Let's talk about 7.5 nonlinear functions. Well, let's take a look at the vocabulary. Nonlinear. Non means not, and linear means straight. So these are not going to be straight lines. I like to call them smiles, frowns, and lightning bolts, and I'll explain. Okay, and the vertical line test is just like the pencil test that we talked about on page 183. So you might want to look back at 183 and just refresh your memory. Okay, so down at the bottom of page 186, I want you to take these extra notes, okay? And naming graphs, I'm going to say is as easy as 1, 2, 3. Okay, let's talk about number 1, linear, which we've already talked about a lot. But I want you to kind of use your hand right now and stick your thumb straight up so that you see that linear, if you just have one thumb up, would make that straight line. And this is anytime x is to the first power. Now remember, when we were doing slope-intercept form, we'd always say y equals, and then there'd be a number in front of the x, m, which was the slope, times x to the first power, but the first power was invisible, so just times x plus b, and b was the y-intercept. But I want you to notice something, how x is to the first power, and that always would form a straight line, and that's what we did all through chapter 6. Okay, now let's talk about number 2. And number 2, if you would hold your hand up like this picture, where your thumb and your pointer finger kind of make this U shape. Okay, that's what we call quadratic in algebra. And that's any time that the function has x to the second power. So this looks like y equals, and there'll be a number in front of the x, we call that a, and then x to the second power. That's what makes it quadratic. And now there's two things that could happen. If that number a is a positive number, then that means when we graph it, it's going to form a smile. It's going to go up the curve. Now, if that a is a negative number, it's going to go down like a frown. Now, the correct word for this shape in math is called a parabola. All right, take a look at number 3. Okay, so I want you to try to hold 3 fingers up, and I took a picture of my son doing it so you could see it. So let's say you had your thumb, you had your finger, and then you had a thumb of your other hand, or a finger of your other hand. And you see this shape that looks like this curvy shape? Well, that's anytime x is to the third power. So if I had y equals a times x to the third power, then it's going to be these cool lightning bolt shapes. So if the a is positive, it's going to look like this, okay, this shape. And if the a is negative, it's going to go the other way, like this. And these are called cubic functions. Okay, so now you're ready to look at example 1. They want us to graph the function y equals 3x to the second power. Well, I wrote it over here. The first thing I want you to notice is x is to the second power. So if it's to the second power, hold up your thumb and your finger. You know it's going to be that curve shape. All right? But see how the number in front, the 3, is positive? That means it's going to be a smile. It's going to go up. All right, so now let's make a table. So we're going to do the x and the y table. And for x, we're going to substitute in -2, -1, 0, +1, +2. Now remember, y equals 3 times x times x. So I really want you to show your work on these, please. So put 3 and then leave parentheses and parentheses to replace the x. So we're going to replace the x with a -2 and a -2. So let's start here. -2 times -2 would make +4, and 4 times 3 would give us +12. So start at the origin, go to the left to -2, and then get in the elevator and go up to 12 and put a dot. Okay, now let's do -1. So 3 times -1 times -1. Well, I start -1 times -1 makes a +1, and +1 times 3 gives us 3. So let's graph that point. So start at the origin, go to the left to -1, get in the elevator, go up to 3, and put a dot. Okay, let's input 0. So 3 times 0 times 0 just makes 0. So let's graph the point 0, 0. That's right at the origin. And then let's put in a +1. So we have 3 times 1 times 1. Well, that just makes 3. So start at the origin, go to the right 1, and go up 3 and put a dot. And then let's input a positive 2. So 3 times 2 times 2 would just make 12. So we're going to start at the origin, go to the right to 3, and then go to the right to 2, and then get in the elevator and go up to 12 and put a dot. And then notice how I switched from the blue to my pencil. I just want you to sketch a curve, okay? It is not a V shape. It's a smooth curve. And notice how it's a smile. It's going up. Okay, now this one, I just want to talk about how we would predict what the shape would be. So notice how the function is y equals 4 times s to the second power. So I wrote it right here. So s is like the x, okay? And notice how it's to the second power. That means so hold up your thumb and your finger. So you see it's a curve shape. And then look at the positive 4. Since it's a positive 4, it's going to go up like a smile. So this would be a smile. And remember, the correct name for this curve shape is called a parabola. Okay, and take a look at example 3. We're just going to predict the shape. So it's y equals 0.25 times x to the third power. So I wrote it over here. And the first thing you want to do is look at the x and look at the power that's touching it, the 3. So you want to hold up your thumb, your finger, and a finger from your other hand. So you can see that it's that lightning bolt shape. Okay, and since this is positive, we know it's going to be the positive lightning bolt. So it's going to be this lightning bolt here. That would be the shape if we graphed it. And we'll graph some on the next page. And remember, this is called a cubic function. When it's to the third power, it's a cubic function. Okay, so let's graph some of these. Take a look at number 1. The first thing we're going to do is predict what it's going to look like. So look at how it's y equals negative 1/3 times x to the second power. When the x has a second power, hold up your thumb and your finger. So you see it's going to be a curve, right? A parabola. But see how this number in front is negative. So it's going to go down like a frown. So you should predict it before you graph it. So let's put in some values. So under the x, I want you to put a 0, a positive 3, a negative 3, positive 6, and negative 6. And then the reason I picked 3 and 6 is because the denominator is 3, and I want the answer to turn out to be nice, easy integers. Okay, so now I wrote out negative 1/3 times x, and I put in a 0. Well, 0 times anything makes 0. So on my graph, I just plotted the point 0, 0. Okay, then let's input a positive 3. So it's negative 1/3 times 3 over 1 times 3 over 1. Now, use your blue and you can cross cancel those 3's because 3 goes into 3 once. So they cancel out. So negative 1 times 3 would give me negative 3 on top. 1 times 1 times 1 gives me 1 on the bottom. Well, negative 3 over 1 is just negative 3. So let's graph that point 3, negative 3. So start at the origin. The positive 3 tells me to go to the right 3. The negative 3 tells me to get in the elevator and go down to negative 3 and graph that point. Okay, now let's input a negative 3. So I have negative 1/3 times negative 3 over 1 times negative 3 over 1. Well, this 3 and this negative 3 cancels, but don't lose the negatives, okay? So a negative times a negative made a positive 1, and then positive 1 times negative 3 made a negative 3. So now let's graph the point negative 3, negative 3. So start at the origin, go to the left to negative 3, get in the elevator, go down to negative 3, and graph that point. Now, I showed you with positive 6, you would get negative 12. So go to the right to positive 6, go down, way, way down to negative 12. And then negative 6 would also give me negative 12. So I'd start at the origin, go to the left, negative 6, and go way, way, way down. And I just did that so you could sketch it. So when you sketch this parabola, remember, it's a frown. It's going to point down. Okay, take a look at number 2. Y equals negative 2 times x to the third power. Well, because x is to the third power, we know it's going to be a lightning bolt. Because that number in front is negative, we know it's going to be the bolt that starts on the negative side of the x. Okay, so let's put in 0, 1, 2, negative 1, and negative 2. So when I input 0, remember I have negative 2 times x times x times x. Well, 0 times anything is 0, so graph the point 0, 0. And then when you put in 1, it's negative 2 times 1 times 1 times 1, which is just negative 2. So if I graph positive 1, negative 2, I get this point right here. Okay, now let's put in positive 2. So I have negative 2 times positive 2 times positive 2 times positive 2. Well, that would give me a negative 16. So if I went to the right 2, I'd have to go way down to negative 16. That's off the graph. Now let's do negative 1. So negative 2 times negative 1 times negative 1 times negative 1 actually makes a positive 2, because remember, these two negatives make a positive and these two negatives make a positive. So I'm going to graph negative 1 comma positive 2. So start at the origin, go to the left 1 and up 2 and put your dot. And then I showed you when you input negative 2 and you multiply everything, you get a positive 16. So I go to the left to negative 2 and then way up to positive 16. And then take your pencil and sketch this curve, okay? It's a lightning bolt. All right, take a look at number 3. So I have y equals 3/4 times x to the third power. Again, see that power of 3? We know it's a cubic function. It's going to be a lightning bolt. And because the 3/4 is positive, it's going to start on the positive side and then curve around. So if I put in 0, 3/4 times 0 times 0 times 0 is just 0. So graph 0, 0. And then if I put in a positive 2, well, 3/4 times 2 times 2 times 2, the 4 would cancel 2 of the 2's, because that's 4 divided by 4. So that just leaves me 3 times 2, which is 6. So I'm going to go to the right 2 and up 6, and I graph that point. And then I did negative 2, and that gave me negative 6. So I went to the left 2 and then down 6. And then sketch a really smooth lightning bolt. Okay, now example 4 is just using that pencil test that we talked about last time, okay? But what I would suggest you do is do what I did for choice A with your pencil or a black pen. Make the x-axis stand out and the y-axis stand out. And then with your blue, go over that V-shaped graph, okay? And then when you do the pencil test, you'll see no matter where we put the pencil, and remember, hold it straight up and down, it only touches the graph in one spot. And so, yes, choice A would be a function. Take a look at B. With your black pen, make the x-axis stand out, make the y-axis stand out. Now with your blue pen, go around that circle, okay? And now, if you held your pencil up, straight up and down, do you see how it would touch the circle in more than one place? It would touch in 2 places. So that means no, it is not a function. And then take a look at C. Go over with your black pen the x-axis and the y-axis, and then with your blue pen, go over that flat line, okay? Now with your pencil, hold it straight up and down, and notice how no matter where you put it, it only touches the blue line in one spot. So yes, that would be a function. And then look at D. With your black pen, make the x-axis stand out, the y-axis stand out, and with your blue pen, do that lightning bolt, okay? And so hold your pencil straight up and just move it around, and you'll see no matter where you move it, it only touches the blue graph in one spot. So yes, that is a function. And so they explain it down here in words, but the only one that is not a function would be choice B.